Okay. Hi, everyone. I'm Kyle.
I'm Karthik.
I'm Andrew.
So first, I'm gonna start off by explaining what the experiment is about. So in this experiment, we pretty much just made supercapacitors, which are basically like a medium between batteries and regular capacitors, because they can store the energy that batteries store, but they also have like the power of capacitors. So batteries, the way they store energy is they have chemical reactions in the middle or inside, which is why they don't really have like a strong burst of energy as much as they can like store energy. So they're used in like devices like cars and like computers and stuff that like needs to stay on for a long time, as opposed to capacitors, which don't really store energy that well because they sort of have a sudden burst of power instead. And the way they work is that electrons move in between oppositely charged plates. And so an example of like a capacitor would be like a camera light, or a camera flash, which sort of just like doesn't need to stay on for a long time. It's just like a flash and then it goes off. And so supercapacitors are basically like in between both the battery and the capacitors.
Okay, so I'm going to be talking about the picture. So over here, so there's 3 pictures in total over here. And as you can see in each one at the top, there's going to be a body of water. And so, as Kyle said, the batteries have the most energy. So in the first photo, you can see it's the largest body of water compared to the other 2. So then you can assume that that's where the most energy is. And we can assume the first picture is a battery. And also because right here is the power, where there's a lot of small holes, which means there isn't as much power as energy. And so the third picture is going to be a capacitor. And so it's because it has the smallest body of water, which means it has the smallest amount of energy. And it has big gaping holes through the dam, which means it has the most power. And then the second photo is going to be the supercapacitor. And it's because it has, it's in the middle between these two for the size of body of water, which means it has the second highest amount of energy, and it's flowing through over the top, which means it has the second highest amount of power. So it's kind of, you get the best of both worlds. And when we're talking about energy versus power, we're basically saying that power is really just defined as energy over time.
Okay, so in our lab we didn't do this, but there's actually a way to turn a capacitor into a supercapacitor. And the way you do this is if you look at the equation for capacitance, which is basically just the measure of a material's ability to hold electric charge. And capacitance is given to you by the equation C. Capacitance equals a constant, which depends on the type of material you're using, multiplied by the area of the charged plates divided by the distance between those 2 charged plates. So if you want to increase capacitance, you could either, or do both. You could increase the area of the plate, so the plate's larger and more electrons can jump back and forth between them, or you can decrease the distance, where if the plates are closer, the electrons don't have to jump as far. And I think they represented the increase of area here, because this is they wrote here this is a dam, so you have more water overflowing the dam. That represents just more area where the electrons can travel. But in this example, it's just more water. And sadly, I think they tried to, but I couldn't see a decrease in distance. So if one thing could be improved about this drawing, it's that they could have represented how you can turn a capacitor into a supercapacitor by also decreasing the distance, which is not represented. But in good drawing overall, it's really clear for us to decipher. Are there any questions? I don't necessarily think so. I don't think distance is represented here, but that could be interpretation. That's something we didn't think about. Any questions about difference between batteries and capacitors? Yeah?
So it's kind of known that capacitors don't necessarily use chemical reactions to like transfer power. Like with capacitors, the electrons move from a positively charged plate to a negatively charged plate, whereas like in say like a battery, like a lithium-ion battery, it's a chemical reaction in which the electrons
Better, better. I don't think they've I don't think they've in this drawing. I think they just captured like the high energy reserve of the battery as its like its defining point, and its low power output as its second defining point. And for the capacitor, it's the opposite. You have very low energy reserves, but you have extremely high power output. So I don't think they were aiming to so much as capture how a capacitor, how a capacitor is built or constructed differently than a battery, and vice versa. They're just trying to describe their two most prominent attributes. If that answers your question. You?
So I noticed that the water sources has some fish swimming in them. Do you think that means anything?
Right. So I don't think. I think the fish are there just because the artist really likes fish. I mean, this person has drawn like a lot of aquatic examples in the past. So yeah, this person just likes fish. I hope that answers your question.
I have a question.
Yes.
So forgive me if you said this and I missed it, but can you elaborate on how in the actual lab you had an increased surface area?
In the actual lab, we had an increased surface area because we had very fine carbon powder, and we mixed isopropyl alcohol as well as citric acid and another ingredient whose name that I forgot. We turned this powder into a really fine dough, and we increased the surface area of this dough just by kneading it, forming like the thinnest layer possible so that it spreads out over a larger surface area. And depending on how thin you could get the dough, that's your surface area, basically.
So which ingredient made the high surface area then?
The dough.
But what ingredient in the dough actually made the high surface area?
I want to say the isopropyl alcohol because it made the dough easier to knead.
Can you think of a different ingredient that might be the
Maybe
actual one?
citric acid?
Nope. Keep trying. Think about it.
Was it the carbon?
Yes.
Because
So
it was like really small, so then like the surface area to volume ratio is high.
exactly. So it's a high surface area carbon that you guys actually use. And you did flatten out the dough to also have most of that carbon try to be exposed, but it's really the carbon itself that is the high surface area. Can you guys explain, like, relatively speaking to just like a flat, piece of metal or a dielectric, how much more surface area the carbon actually has comparatively?
Comparatively, in our post-lab analysis, we found out that you would need probably somewhere over 11,000 square meters of surface area to just I think light a light bulb for 10 seconds, and that is 2.2 football fields of area. But surprisingly, it's only 5-point-something grams of that carbon powder that we used, so a lot.
Yes. All right, cool. Any other questions from the audience? One more question, yes.
The supercapacitors are supposed to release less energy or less power than the capacitors, or are they supposed to release more?
All right, so good. Her question was, are supercapacitors supposed to release more or less energy than regular capacitors? And I think the answer is less, but I can see why the drawing's like kind of confusing. It's because supercapacitors are kind of the bridges between batteries and capacitors, where they don't have the super like energy storing ability of batteries, but they don't output like the crazy amounts of power capacitors do. But they're, huh? I don't think the picture's wrong. No. Yeah, but I think ultimately their goal is that this produces more water than
Oh no.
this produces more water than this. Like more, it's a bigger power output. It's not clear. It took us a while to decipher, but we got it in the end.
Can the artist for this one maybe stand up and try to clarify the question?
So, for the capacitors, I was trying to have like giant pipes coming from the body of water out, so it's like pushing out water at a much more rapid rate than the supercapacitors. That's like supposed to not be like a lot of water coming out, just more surface area for the water to be flowing over rather than a lot of water coming out. Yeah, the first one is supposed to show like smaller power output, but a larger energy source from it.
Any more questions?
Any other questions? If not, then let's thank our artists and our presenters.